Thank you very much, colleague. So my name is Gil, right here. This is my email contact. Feel free to contact me. I am learning technologist at the University of Southampton and associate lecturer at the Open University teaching on design model. And today I'm going to ask, how can we reimagine data using art and AI? So I was given 6.5 million words. 6.5 million words. And how can we take 6.5 million words, which were digitized and appear as data sets, and how can we turn them into art form like this one? 6 million, how can we make them into art like this art form, or like this art, which represents the data, represents the report, or these three different projects, three different arts. Let me explain. So we have 37 volumes of discovery reports. These are ship-based investigations carried in Antarctica between 1929 and 1951 by British scientists paid by the British government. All the reports were then published, then digitized, and now they are shared by the University of Southampton, and anybody can download it. You can download the data sets. And my job was to re-envision it and revisualize it in some way. So the first step was to take them, the 6 million words, into ChatGPT, ask ChatGPT to come with theme, then with proportional parameters, I will explain, which then I have translated or mapped into visual compositions, and the visual composition we then turned into art. I've actually also produced a song based on this same data and a full playable game board, like Monopoly game board based on the data. But today I'm going to talk only about the art that was created. When we think of art, we think of a few different formats, few different ways to represent data. One is data visualization and one is artistic visualization. Now, these things are two very different things. Data visualization is when we take a lot of information, and we try to make clarity and structure. We do so by turning data into charts, maps, graphs, or images. You've all seen maps and charts or images that try to make the pattern, the relationship between the information easier to understand. This is data visualization. It's a process of creating chart and map. That is very different from art, or as I call it here, artistic visualization. With art, we try to interpret the data. We want to interpret the data to create an emotional resonance. We want the user to feel something when we are creating art forms. The viewer completes the painting. You see, the viewer completes the painting. We don't mean that the viewer take a paintbrush and paint on the canvas and finishes the painting. No, what we mean is that when the viewer looks at artwork, they complete it. It's the complete experience of the painting, the art, including the artist and the viewer themselves. So the viewer completes the painting. That's a very powerful statement, which I've learned from an interesting artist. If you want to read more about this artist, here's the interview link you can look into. So artistic visualization is about interpretation, emotions. It is even about looking at things from different perspectives. So in art, we can tell you, if you stand here, look at the work, it will show you one thing. If you stand on the other side and look at the same work, it will look different. We're not afraid of multiplicity of perspectives. This is something that data visualization would never agree to. Data visualization was to be strict and clear. Here is an example of simple data visualization, the most simple chart, graph. You have all seen these things. You have the numbers, we know exactly what it means. And on the other side, artistic work that you see right here, created by an artist called Janet Eckerman, who took tsunami data sets, so tsunami data, which then inform the shape of a net that she has created. This is a massive net. If you look right here on the right, it fills the whole ceiling. When you look up, this is what you see. And the data sets from the tsunami, real data, inform the shapes and how light is rendering the material. And the whole idea is to make the ocean movement visible. So this is an illustration of the ocean's movement. Beautiful, artistic, but you will not have the numbers from here. So you see, I have the challenge because I am both an academic designer, I do data visualization, but I'm also an artist. I go wild with my creativity. So I have a challenge. But what I have found is that both formats, right here, both formats do the same thing in that they try to take the invisible and turn it into visible. Both formats try to translate the invisible system into a perceivable form, which is good for me. And my work indeed ended up being right here at this point, between data visualization and artistic visualization, or in other words, encompassing both worlds. What I mean, for example, in this work right here, the work is very creative, but it is grounded in the data. So what you see here is visualization of the 6 million words, and I will explain in a minute how I did it. But you can clearly see that it was expressed in an illustration of a cup of tea or cup of coffee. That is the creative aspect. But still, this is very much grounded in data. For example, the amount of blue color that you see here, the blue color is not random. It represents something from the report, from the data, and it is spread across the page in percentage in parallel to that specific data. I will explain. So the first step was to take the data sets, the report, the scientific report, and throw them into my trusty friend, ChatGPT. Well, trusty friend, I'm not sure I would trust ChatGPT, but they're definitely a friend. I asked ChatGPT, my good friend, to come up with recurring themes. So to read everything on those reports, the scientific report, and come up with the main themes that are expressed in the report only. Not to come up with anything from elsewhere, because ChatGPT will bring information from elsewhere. I was specific, and ChatGPT came up with these things that are mentioned in the scientific report: water, whales, plankton, and fisheries. Then I made the decision, I'm going to focus on water only in my visualization. That was my decision. I could have decided anything else. But if you think of this, whales and fisheries, they live inside water. So I said, let's stick with water. Then I went back to ChatGPT and I asked it to categorize water, to give me what are the properties of water. Again, not to invent, because ChatGPT can invent, but rather the categories that are expressed in the reports, in the 6 million words scientific reports. ChatGPT came with those answers. So the report that the scientists discussed: boundary water, circulatory, stratified, nutrient, and ice. This is relevant to the datasets. There's no invention here. Boundary water is where cold water, cold Antarctic water meet hot waters. Circulatory water happens because of this drift, these winds that happen in Antarctica. Stratified water is when you go down in layers in water. There's different temperature to the water, which affect the nutrient. And ice is basically when Antarctic water extract and contract. The next step was to quantify those categories. So how many times they were discussed in the report? Boundary water were discussed around 21% and so forth. At that point, I had the topic water, the type, the categories, the properties of water, and how many times it was mentioned in the report. How many times? Next step was to start to create color encoding to this data. Boundary water, for example, is where cold water meets hot water. Okay, so hot water is your standard ultramarine, and cold water, the icy water, will be white. So in the artwork, when I'm going to represent the boundary water, I would use white paint versus ultramarine. Nutrient, the nutrients, were first represented in green. These are a nutrient that fish would eat, and then whales would eat the fish. So that's why they're crucial to the Antarctic exploration, which looked at the fishery and whale population as well. So nutrient, I thought, okay, that's something that gives life. I thought it should be green, nature. But the color green did not look well in one of the artwork at the end. The color combination simply did not look okay. So I've changed it. Remember, partly artist, I can make those changes. And I decided it's going to be gold color. Now, gold, yellow is also relevant. Gold talk about value, vitality, but also sunlight. And sunlight is relevant because the nutrients are dependent on how much sunlight enter the water or not. So that was relevant. So I had water types, how many, and now I also had colors. Then the composition, the rules around the actual design. Again, boundary water, we know it is about hard edges. It's when cold water meets hot water. So it's hard edges. Therefore, it will be represented as dividing sharp lines. In the artwork, dividing sharp lines would represent boundary water. And each water was given the visual encoding that I will use for creating the artwork. So at that point, we had water, the theme, the type, how many colors, and the compositional rule. This has produced vocabulary that now I could take and create artwork. So I went to my friend ChatGPT, and that's what it created. The first artwork created based on that. So if you see clearly, we said that ice cycle was mentioned around 25% ice cycle. And therefore, if you look carefully, the color white covers about 25% of this image, the color white. These are the circulatory water, for example here, which are affected by the weather drift. This is not random, this is not invention, this is actually mentioned in the document. These are the nutrients represented in yellow, gold, speckle, and so forth. Here you can see coordination line, 0, 40° east, 80° east. That is not random. That is because the ships did anchor at those coordination lines, and then they measured the data, the ocean. So everything here is relevant, but this is not a graph. This is artistic visualization. Or the second example is this, which is more creative. Here you can see that we talk about stratification, the depth of layers. Surface is represented with light blue. Deep color, deep blue, is for deep layers. And indeed, here you can see dark blue, dark deep blue, which represent deep waters. That is relevant to the scientific exploration. When we talk about the nutrient represented here in gold speckles, gold yellow, as you can see here, and they were created here in this region where the dark blue is, because dark blue represents mid or deep water, and indeed, according to the data, the nutrients were found in mid waters. So the system did not draw it right here at the top, because that's not mid water. The system drew it in the correct place. Very artistic, but authentic to the data. Now, there is one problem here, I would say, from a visual perspective. You see these gold, yellow speckles. They are so bright that it seems as if they are on top of the surface. It doesn't look as if they're in the inside of the surface. And I'm speaking now as a graphic designer. So it looks as if it is on the top of the surface. It is drawn in the right place, in the deep area, but it doesn't draw so well. That's not a problem. I can fix it in Photoshop if I need to. If we're talking about ice, it's the behavior of water that expand and contract. So look right here. The way that it expands is that water will push to the side. So from this berg, from this area, water will push to the left, for example. And if I stand right here, the water will push to the right. And where they meet, they converge, and that's where the ice would break. So those pattern of cracks, of breaking that you see here is not random. It's authentic to the cycle of the ice as presented in the documents. So what I'm showing you here is that I was bound to follow the numerical system. I was bound to follow the numbers because the brief was represent the data sets. I was bound to follow it. But still there was so much scope for creativity and interpretation. I find it that we're always limited. Whatever project you are given, you're always limited. Time, budget, money. Sometimes the brief will tell you you have to use only 2 colors, black and red. That's it. They don't want to put more than 2 colors. Only 2 colors, but there's always some scope for creativity and interpretation. Like the next work, this work, which is very creative. This is the same visualization of the same data sets, but now I thought, let's do work after famous artists. So this is after Kandinsky. This work is not Kandinsky. This is my ChatGPT work, but it is after Kandinsky. Is it pretty, by the way? Probably not, but that's not the question. It's not about aesthetic. It's about creativity and representation. Everything you see here, again, draws back from the original stats, from the original data, from the 6 million words. First, I chose Kandinsky because he focused on movement and inner forces, so it's relevant to represent the inner forces of the ocean. But now let's look at the categories. We talked about boundary waters, for example. We said boundary waters will have hard edges, intersecting line, when we represent them visually. So in the Kandinsky composition, it was decided that a thick black linear structures or line would cross the center, cutting through the colors forms. So here we are, strong, thick line, cutting the form. That is not one-to-one representation. That is very creative representation, but it is authentic to the data. There's the meaning and reason for everything. If you look here at the blue waves, it's a blue wave. It's actually represent the oscillation of the water, of the ocean water. If you look at the yellow speckles right here, so these are representation of the nutrients, which we design are going to be yellow speckles. So here is another project, the second representation of a famous artist. Here on the right, you will see the beautiful Piet Mondrian artwork. Here on the right, that is the real work of Piet Mondrian. I looked at Piet and I had a vision in my mind to take the frame. So you see the grid, the black line, the famous grid of Piet Mondrian. And I said, I want to take that. I want to turn it into an image of a metal grid or frame that you can see here. And I want to lay it on the ocean. That is an image that came to my mind. That's the artistic aspect. It's a vision. I saw it. I thought of Piet Mondrian. I thought about my project, and the image came to my mind. This is not drawn from the data. That was the creative aspect. And so I asked ChatGPT to do it. And then everything and anything else that you see here represented the data. So the amount of the framing, the actual physical amount of the frame, and the different colors that it bounds here represent all the winds, all the deep waters, and so forth. I made the decision to create circular frames. As you can see here, you will not find it with Piet Mondrian's work. I made that decision because I needed to represent the circulatory water. And right here, you see the nutrients, the yellow nutrient. By the way, this is where the nutrient were with green color initially, green on top of the blue, and it looked like moss. Moss does not represent accurately those specific nutrients. So I made the change into yellow right here. And the third representation after a famous artist is after Rothko, the great Rothko, who used vertical stacked color field. And once again, there is a reason for every single shape and the amount of colors. This is the yellow color for your for the nutrient, for example. For every single artist, I explain exactly every single decision in this table and other tables. If you're so inclined to learn more, here is your link. Read this link from the University of Southampton Digital Scholarship website, where I do explain all the decision behind making and how they relate to the original data. So colleague, as you see, this experiment starts with dropping a lot of text into ChatGPT and extracting the themes of the content, this scientific report, then choosing one. I chose water, then categorizing, defining categories, properties for one theme, for water in this case, quantify them, and remember the quantity comes from the datasets. How many times was this quality discussed in the dataset? And therefore, that's exactly how many times it will be represented in the artwork. So quantifying the categories, circulation, hours, and boundary, and so forth, mapping them into the visual rules, which mean color, form, space, line, shape. And the visual rules will then follow the category. It will represent a category, but also quantity, also how much the category was represented. This experiment up to here was text-based. So I was writing to ChatGPT and ChatGPT was writing back to me. From here, then I took the text and I asked ChatGPT to now create the images, to create the visuals. So 6.5 million of words, yes, colleagues, there are constraints. There are constraints from the data, but this shows you that even with constraint, you can find a creative spot. Constraints do allow for creative expression and creative output. It is possible. Also, it shows that art and science perhaps operate in a tension. Science is very specific, that's great, and art want to be anything but specific, want to be the opposite. So they do have some tension, but I find it to be productive tension. Yes, there is tension, but it's productive. These things I'm showing you are productive, they're creative, they're interesting. And I would say something here that some of you perhaps would disagree, and I would love to see what you think. I would say that art visualization, so this artistic work, I would say that they expand meanings beyond explanation. Explanation is the data sets, it's the data, it's the number. I call it explanation. I would say that those creative artwork, those creative visualization, they add another level of meaning, and I'm referring to meaning. I believe that when you look at this artwork visualization, it creates emotional connection with the topics, which produce some sort of meaning. If you like, I would argue that emotion, that visuals, they have meanings in the same way that numbers do. You may disagree. That's perhaps a chat for a discussion for a different time. But perhaps you would agree with me that it can still help you. So if you look at this work, it creates some connection with the data that then can help you connect better with the numbers. So there is definitely values to the art visualization beyond the number, beyond the graphs and beyond the maps. Colleague, thank you very much. This is a very different work altogether. If you're interested in AI-generated music, go to this link. I have created 8 albums which are AI-generated music, fully AI-generated. If you're interested, that is your link. You can look at any of the albums, but here in this album called Redemption, I'm explaining the process if you're interested, colleagues. So that's your Redemption, that's the album to look into. And I call this Human Creativity with AI Delivery. I should say human creativity as well as human direction with AI delivery. So I'm Gil, this is my email right here, and I think we have 5 minutes for questions.